Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the sixth question from the preliminary exam which was written in the year of 2024 in the province of Mpumalanga. Please do expect a total number of 9 videos since the question paper had 9 questions in total, and that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write a preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Excuse me. We are given the equation of f of x. We are supposed to determine the derivative from first principles. There is an equation we use guys to find the derivative from first principles, right? It simply says f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Remember that guys, f of x is equal to negative 2x, therefore f of x plus h will just be equal to negative 2 over x plus h. So I'll simply have limits as h approaches 0 of, let me erase here, of negative 2 over x plus h minus negative 2 over x. This is all divided by h. I have limits as h approaches 0. This will just give me negative 2 over x plus h plus 2 over x. Negative and negative will give us a positive. And then the denominator is just equal to h. The whole entire purpose, guys, for us to find the derivative from first principle is to substitute h with 0. But right now we cannot do that, because if we do so, our denominator will be 0, and hence the entire expression will be undefined. So right now, guys, we're trying by all means to remove that h over there before we substitute. And also guys, whenever I deal with numbers or other fractions, I just want to have whole numbers divided by whole numbers, not fractions within a fraction. So I can remove these denominators that are within the fraction. I can simply multiply the top and bottom by the same lowest common denominator. The only lowest common denominator we have is just x into x plus h. If I multiply the top and bottom by that, I will end up having limits as h approaches 0. I'll end up having negative 2x plus 2 times the bracket into h, x, and x plus h. There's limits as h approaches 0. I can simply remove brackets there at the top. I will have negative 2x plus 2x and then plus 2h is divided by x, h, and then the bracket over there. The two h's the two x's rather will simply subtract one another. I'll be left with limits as h approaches 0 of 2h over hx into x plus h. The two h's will therefore cancel one another. How so? Like this will cancel that. I'll be left with 2 all over x and then x plus h. Right now, guys, I can simply substitute h as 0, because by doing so, the denominator will not be equal to 0. So I'll end up having 2 into x times x plus 0. This is just 2 all over x squared. So the derivative is just equal to 2 all over x squared. So the derivative over here, guys, I have 2 divided by x squared. And then now for 6.2, I'm supposed to determine the derivative of y with respect to x if I'm given that particular equation. Okay, if ever, guys, I'm finding the derivative, I must make sure that the variable I'm supposed to derive is not inside the bracket. The variable I'm supposed to derive is not in set form. The variable I'm supposed to derive is not at the denominator as well. And therefore, if that's the case, I can simply use the fact that if f of x is equal to a times x to the power n, therefore the derivative will simply be n multiplied by a and then x to the power of n minus 1. Over here, guys, for me to find the derivative, the first thing I need to do is to isolate y. Okay, remember that I'm given the equation as xy minus 2y into x squared minus 4. Okay, I can simply factorize my left hand side. I can take out the common factor there, which is y, and then I'll be left with x minus 2. On the right hand side, guys, I can also factorize because I have a difference of 2 squares, right? I have a difference of 2 squares over there. I can divide both sides by x minus 2. If I divide both sides by x minus 2, this will cancel that, and these two will also cancel, and then y is just equal to x plus 2. Therefore, the derivative of y with respect to x is just equal to 1, because the derivative of x is just 1 and the derivative of a constant is 0. So dy over dx is equal to 1. And then over there, guys, I'm given the expression there that's d of x is just inside the bracket I have the fifth root of 32 over x cubed. Okay, according to the laws of exponents, guys, if ever I have a and then I have b, I have x over y, this could be written as the 8th root of a divided by the 8th root of y. Same thing applies there, guys. D of x simply tells me to derive with respect to x. I will have the 5th root of 32 and the 5th root of x cubed. So this will just give me dx. The answer over there is 2 all over the 5th root of x cubed. There's another rule that simply says if ever you have x into p to the power a, this can be written as p to the a all over y. Right, together, the root of a number is always the denominator of its exponent. Remember that, guys. I'm trying to remove the set, and secondly, I must try to remove the variable I'm supposed to derive from the denominator. Okay, so problem number 1 will be solved because I can write this as 2 all over x to the power 3 over 5. Now the variable I'm supposed to derive is no longer in set form, and then second, like, I must make sure that it's the variable I'm supposed to derive is not at the denominator. There is another rule of exponent. It says c all over x to the power p can be written as c multiplied by x to the power of negative p, whereby c is any constant. So basically, guys, I can remove this from the denominator by just changing the sign of the exponent. So therefore dx will simply be equal to I just have 2 times x to the power of negative 3 over 5, and therefore I can find the derivative, guys. This notation kept on reminding me that I need to derive the expression inside the bracket. So if the next statement is the derivative, I don't need to remind myself. Okay, so I'll simply have negative 6 over 5 x, and then if I minus 1 over there, I'll end up having negative 5 over 3 minus 1. It will end up being negative 8 over 5. I can leave my answer over here, guys, but if I want to leave it into positive exponents, it will be negative 6 all over 5 into x to the power 8 over 5. That's how, guys, I was supposed to find the derivative there and answer the entire question 6. So please, guys, do stay tuned and wait for more videos. Thank you for your time.